All right, well, hello chemistry students. This is just a video to kind of run you through a little bit of an analysis of the silver nitrate and copper lab that we did the other day. So we ran that chemical reaction the other day. We had to take some time and wait so we could get some final mass measurements. So that would be the first task today. I would remass your copper if you did that on Tuesday, just because there might have been some excess liquid on there that was skewing that mass. So retake that mass. And obviously for number one on our part 2 document today, we're going to need the initial and final mass of the copper to figure out how much copper was actually consumed in the reaction. Your next job would be to take the mass of the beaker and silver that was produced. And for number 2 then, obviously you would just be subtracting that final mass plus silver number and then take the beaker mass away from that. So 1 and 2 are pretty straightforward. Where the stoichiometry kind of comes in is in number 4 here, and I'll kind of give a rundown of what that looks like. But what I have here is the chemical reaction equation for the chemical reaction that we did on Tuesday. Okay, so we reacted copper with silver nitrate. And understand that silver nitrate was in a solution, so that was actually a liquid that we had there. But then our products, obviously we had silver, but another product here was copper nitrate. So just based on that chemical reaction equation and your observations from lab, I want you, with your group members, to consider what that blue solution was that we saw in the test tube. Now for number 4, and actually before you do number 4, I would like you all to find the molar mass of copper, silver nitrate, and of silver, okay? Because obviously when we start doing our stoichiometry, we're going to need molar mass values. So in number 4, this is where we are using stoichiometry, that process of dimensional analysis, to determine a mass value for one of our products. In this case, I want to know what the theoretical yield, the final mass of silver would be. Okay, so we have an actual value. That's what we found in number 2. I want to know what the theoretical value is. So your starting point is you need to either pick the starting mass of the copper or of the silver nitrate. And you can get the mass of that silver nitrate, the starting mass, by taking the mass of the vial and the silver nitrate together and subtracting off the mass of the vial itself. Okay, so it doesn't matter which one of these you choose, just pick one. Okay, so I'm going to pick copper, and I'm just going to get this started for you. So let's say that I had 3.56 grams of copper, and I want to end up with how much silver was actually produced, the mass of the silver, right? So again, in our process here, we're going from grams of one of our reactants to grams of one of our products. So this is going to be one of those 3-step stoichiometry problems, where first we need to use molar mass, and in this case it would be molar mass of the copper, right, times our mole ratio, and again we get the mole ratio directly from our balanced chemical reaction equation. And then here, again, we would end with molar mass. And in this case, that would be the molar mass of silver. Now remember, what we're plugging in here are actually fractions, right? Because we need to cancel out units as we go along here. So whatever unit we have here, that unit would have to be in my denominator. So in this case, we would have 1 mole of copper, and actually I'm just going to erase that so you can see this here. So here we would have 1 mole of copper, and then we would have whatever the molar mass is, grams of copper. Okay? So go through that process. Again, you can start with either the starting mass of copper or of the silver nitrate. Now, number 5, this is kind of a new piece of learning. So, again, using the chemical reaction equation, we can figure out a theoretical yield, right? A theoretical final mass value. And that's what we're doing in number 4. But we have actual values that we get, actual mass values that we get from running a chemical reaction. So what we're determining in number 5 is what we call a percent yield. And the equation is very, very simple. So we're going to take the actual yield, so that's going to be your value from number 2 essentially, divided by the theoretical yield. And that's going to be your value from number 4. And again, this is a percent. So once we divide that, we're going to multiply by 100, and we're going to get our percent yield of silver that is produced. Now, number 6 is kind of an extension question, and this is what we're going to take a look at on Friday. But more than likely, your percent yield of silver is going to be less than 100%. I want you to do some critical thinking within your group. Why do you think that's the case? And I want you to try and use vocabulary such as reactants and products in your response. Okay? So this video is accessible to you. Feel free to go through it. You can stop and you can pause, go back, whatever you need to do. Hang on to these documents, and we'll collect those on Friday. And then if there is any extra time left today, please dive into your end of the unit or end of the year projects. All right, see you tomorrow. Take care.